Welcome to Factorio Masterclass. My name is Nilaus, and this is the series of guides and tutorials here on YouTube, guiding you through the wonders of Factorio engineering. And we are diving deep into the most complicated stuff in the game, and that is the basically trains. And it gets worse than that, or better than that, depending on your perspective. It's also about circuit controlled trains, and it gets better than that. We are going to introduce a completely new concept, at least. Well, I think it's completely new for me, at least, when I sort of started implementing it. But the concept is to have multiple trains on the same track and then controlling when they're going in and out. So that's going to be the objective for this masterclass. Hopefully it will inspire you. This comes from my Twitch Let's Play series, and that is streaming live on Twitch TV/Nilaus, and it's Tuesday, Thursdays, and Sundays at 8 p.m. Central European Summertime. So do drop by and just be part of this awesome design process. Let's start by taking a look at what it actually is we are doing here. So what we are doing here is we are going to make, well, maybe I'll even, okay, I'm running on tracks, that's not safe. I am going to run down here to some green science. That will be right here. This is going to be a much simpler setup, but it will illustrate the point anyway. Because when we, in our previous train-to-train setup, I talked only about the smelting, and I'll just briefly go up and show you some smelting. We have that here. This is quite simple because, comparatively, because you have one train inbound and another track that takes the outbound. What if you have three components, such as green circuits, where you have copper and iron coming in and green circuits coming out? You can't have three tracks and then do train to train, so you've got to share some tracks. That is what we're doing here. So you can see in this case how that is working. You can see that iron is being taken from this train and going back out again. These ones could very well be set up to some more. Let me just check. This is 53 and it has to go below 50 before it starts. And pretty sure it goes. We'll come back to the circuit and how we control it. So basically what we have here is we have iron coming in, and also on the same one we have the green circuits coming out. The other one will be exclusively for the copper. You can do it the way you like, but this one I can actually make it. So what are the challenges for this kind of setup? Well, there are two different challenges. One is, as we described previously, the how to design the setup here. In this case, I have done this setup, and I am super happy about it. It is actually a double setup, so instead of tiling on 7 tiles for one wagon, it tiles for 14 tiles. You can see here, this is 14 tiles, and reason why it has to be 7 or 14, because it has to fit with the trains, so that the trains are always in line here. I am just so hoping that I'll get another train that comes in here, just so I can prove a point. We are going to follow this train as it gets empty. This green circuit train here, you can see, oops, on the right hand side, it is almost empty, and it will be empty, boom, like that. So we will see this one coming back to our green circuit build, the ones we were sort of hovering over, and we'll see that how it works. So it goes in here, because this green circuit is in an idle position, and it goes in and it doesn't run me over, so that's very nice. Now we can see how it works. One of the important things is you must block this, otherwise you can risk that some things get out. Also, you must make sure that this one doesn't empty whatever, but it only empties the iron plates. So between these two things, everything will be fine. This train will be filled up. I will go all the way down here. It'll be filling up, but one thing that you will notice is that it fills up quite slowly because I only have one here. So what is it we want to do? There are two things, as I mentioned, that we need to control. One is make the design here. This design will be provided in the blueprints that you will find in the description below. So they are always available, and if you want to sort of get the full map and all the builds here, then that is available to patrons through the Discord. So that's the way that works. This is the one thing, the design here. The other thing is the controls, because you can't really have both trains coming in at the same time. Oh, look at that, beautiful as these go out. You can't really have both a green circuit coming in and also an iron train coming in at the same time. So you want to make sure that when one comes in, the other one gets blocked. I have 3 lights out here. This is of course something that I haven't designed myself, but with good feedback and inputs from the community. This out here is pretty damn simple. It will basically just monitor on either side here when the amount of copper in these ones go down below a certain threshold. It'll monitor all of this. Normally it would have on both sides because it's a repeatable pattern, but this is a small setup here. However, it'll go into here and then basically saying when it's less than 50,000, I will summon another train coming in here. So, and that's why the light is also on. This one sets when it's less than 50,000, I'll set the train limit, the L here, to 1. So until then, no trains come in here. There's no point in bringing in a train if it cannot unload. And that's what it seeks to do, getting in here and unloading. That's the simple one. We kind of want the same thing here. We want to monitor how much iron we have, and then if it drops below a certain threshold, I would like to get an iron train in. But in this case, even though it has dropped below the threshold, there's only 21,000 iron left, and this threshold here is less than 50,000. So it really would like to get an iron train in, but it can't do that because there was a green circuit train. So now there should be an iron train coming in. Fingers crossed, and I see huffing and puffing. That is the train coming in. Great. Train is coming in and starts unloading, and by the time it gets in here, it was down to 17,000. So yeah, it was low, but it was not critically low. And this one goes in, unloads. We're going to go through this logic up here because there are 3 signals. One is, I think this is the best way of explaining it in more of a, would it like to get one? It's the first one. That means, is it less than this threshold, 50,000? Then the train basically says, yeah, I would like to be able to get an iron train in. That's what the station says. It has a personality. The second light here is it allowed to get one? Because it is only allowed to get a train in here if there's not already a green circuit train in. So for example, if I run all the way down here, we will see that the second one, it would like to get a green circuit train in because it has enough to fill up a green circuit train, but is not allowed to. And the last one is there actually a train assigned here? And the answer is no for this one, but yes for the top one, because there is an iron train in. So that's sort of the objective of the different logic, and the way it works is, if we see here, this first one says, is it less than the threshold? If so, it would like to get one. Currently, it would not like to get one. Then it goes, sends this output, the L equals 1, into this one. The G here is a signal that basically is green already there. If green is not there, then it's allowed to go in. But basically, you can see here, the green is 0 because there's not already a green train already loading. We get the green signal from here. This one says the train count, which is either 0 or 1, is output with the letter G, which goes on this wire and goes all the way up. Yes. So that means if there are no green trains allocated, then it sends whatever input goes on. So that means if this is outputting 1L, you will see that now it's 51 for the iron. When it drops below 50, and then it drops below, then I will get that one active and that one active. Boom, and that one active, the last one. This one will then set in here, set the limit to 1. The train will be allocated, boom, and that's why this one will go in. The I is for an iron train. It outputs the output signal I for iron train, which also, and this is important, it is not only the stopped, it is number of trains going to this train stop, including the stop train. Yes, so as soon as a train is allocated, it will set this light up. For example, now it doesn't want anything, and therefore it's not even allowed to get anything, and therefore, but it still has a train here that's currently being unloaded. And we see the value here of the iron going skyrocketing up, and it would be nice to see if we can get a green circuit train inbound. But right now, if there is a green circuit train up here that's currently unloading, there isn't, but if there was, then it would not be able to go out of this location and back into here just yet, because it would have to wait until this one is active. You can see this one's blocked for green circuits coming in because there is already a train waiting here. So this is the way it works. By one train is blocking the other one. So that's the simple setup. This setup here has to connect the 2 stops, and I can then make it slightly more advanced when it comes to red circuits, because red circuits has 3 inbounds and 1 outbound. So that means that both inbound and outbound station will have to be a shared station. We can do that. Sorry. The way that works is I'm going to run on the tracks because that could not be dangerous. What I have here is 2 stations next to each other, and it might actually be easier to illustrate here. I have one for the green circuits and one for the plastic. Are any of them inbound? Nope, none of these are inbound yet. It would be nice if they were, but they. I'm trying to increase my red circuit demand. But one of the key points of this is that it takes a lot of space, but each of them is kind of slow. So that means the trains will take a while to load, take a while to get enough so that the trains to actually get in. You can see this one is waiting here and just being ready. And the funny thing is that one actually shouldn't really be there, right? It can wait over here. As long as it waits over there and doesn't block that stage, it's fine. And actually maybe it should have been waiting there, but that doesn't matter. It's going to be the next one that comes out. It looks slightly less awful at least. So here it's exactly the same. The green circuits says that if it's less than 100,000, get one in. If the one says it's close to 50,000, get one in. Currently it has 66 and 154. So 66 is kind of close-ish. Let me see if there are anyone that's kind of more close. That one is an edge case, so that's less relevant. We want to see the ones in the middle. Let me see if there's something that will be almost soon enough that will get in. Not really. And that's an edge case as well. So I guess the one that is the closest was the one we were looking at before. And that was this one, 65. So once the plastic goes down to 60, less than 50, it'll actually get another train inbound here. But this is how you control it. You set this when it's less than 100,000, it sends it in. It checks whether the P, that's for plastic, and G is for green circuits. I don't want to use the signals, then it gets confusing, but I'll just use it this way. And they cross block each other. And what you have to be careful of is when you have a train here, you must be sure that the input, the design here, can actually unload from that location, as well as when you go 2 tiles up, you also must be able to do that. Let's look at this design as well. This design is also a 14 by 14 tiles design, so that it fits to 2 wagons. You can see here. This looks suspicious to say the least, but it actually isn't. I mean, it should go somewhere that doesn't have that. That's this one. It is extremely important that the copper train here, you can see where the start and end of the trains are. They're exactly there. It's super important that it gets designed like this so that they go into different trains. Basically, they unload, put them into boxes, just let these boxes be filling up. It makes one of these. This is obviously overscaled compared to how much I need. If I look at my rate calculator, you can see that it is woefully overscaled. But, you know, it's still a matter of this is the most efficient way. It will be idle most of the time then. It'll work and then it'll be idle when, yeah, when it's not necessary. This one is idle, for example. You can see, well, it goes idle and it fills it up. And at some point it'll probably just stall for a bit. There we go. It stalls until it drops a bit low. And that's going to conserve updates. These ones, here I can use the red inserters because the red inserters are fast enough. Nothing here is very high speed, so that's why I'm doing this. The reason for these curved things here, like that one puts in here, is because if I put that one out here and that one out here, then it might not actually fit to the station. So I do this, and if I have one of them going up and the other one just going with an extra big module, then it wouldn't be reversed. Well, what's it called? Yeah, I don't know what it's called, but I like this way of doing it. This is the design, 14 wide, and it takes a while to get these kind of designs. It seems pretty simple right now, but it does take a bit of, okay, this just means that it is ready to get something out. We're going to take a look at the green circuit build again down here. This one has, again, if we zoom in enough, that we can see the whole design. And these are not getting as many sources here. The reason why this one is not getting as many is, well, it doesn't need to compare to the other one. I really had to try a lot of different options here, and if I scooted the one further one way or the other, then it wouldn't fit. It's very important that if you look at these, that they are pretty close. It's more if I do something that's, if this one goes faster, then this one won't be able to keep up. And if my circuit build is not able to keep up with the green circuit build, my green, well, if my green circuit build is too fast for the copper wire assembler to keep up, then I won't have enough throughput. Additionally, it's going to be wrong input. So it's really important that this gets slightly faster than that one, which goes out. And that's what we ensure here by this one being affected by 10 effect sources, this one only by 9. And that's why this one has only a slight surplus. If they were both affected by 10, then this one would be too fast and it would be starving for materials down from this one. And that's not good. Again, the design here is pretty crisp. I could not do it as a 7 design because this one here has to go out and out. Just having this small internal buffer here, that ensures that we can use the green inserters, because all of this is way too fast to use red inserters. So this had to be done like this. Maybe you can find a better way. I could not, and I'm super happy about this. Also, then we can look at, this is a, how much is this train? This is a 16.2, and it is still producing a pretty decent 325 green circuits per second. So it's not like, it's not nothing. It's not nothing that gets produced here. And likewise, if we go up to our red circuits, we can also see how much is actually being produced. So even though it seems like it's slow to fill up, then as we look at these, oh, there we go. We got a plastic train coming in. And that one, it's only 36.4 red circuits. But red circuits is notoriously slow. But you can see now here, this one is, actually we're getting some copper inbound. I really like the when the copper comes inbound. This one has enough right now, and it's just a matter of getting this one out. It is almost empty, and it'll be fully empty. What we will see should be that we can now get a red circuit coming in, red circuit train coming in, but I don't think we have red circuit trains. No, they're now not waiting. This one is still unloading at this location, so we're not really filling up any red circuit trains, but we are actually available. We have multiple stations available for red circuits. This one goes in, you can see here, and if I look at this one, there's still a long time until the green circuit comes in. One thing though, you have to be aware of with this kind of build is, are you able to unload the train and get the train out of the station again, and get the next train in and unload in sort of the time that it takes to consume it? Because if the time it takes to go into the station, unload, get out, get the other train in, is more than the time that it takes to consume it, then you're going to run out and have empty buffers. And that's a definite no-go. This case, not a problem at all. And that's something you have to be aware of when designing it. So I hope that you are finding this interesting. I think this is a super interesting design. I'm going to continue to do this. This should also be a lot more UPS optimized, because there are no belts running around. There are basically no belts for these builds I've just shown you. Not basically, there are no belts. It is purely inserters, assemblers, and trains that are active entities going on here, and that makes it so much more effective. So if you find this to be interesting, then do check out my Twitch channel. I am live on Twitch on Tuesday, Thursdays, and Sundays at 8 p.m. Central European Time. The address is twitch.tv/Nilaus, and this is where I built this base and come up with new and interesting design together with the community. So we are having a good old time with these kind of designs. If you want to support the channel and the work I do here, then I also have a Patreon, and it is of course also links in the Patreon in the description below. Basically, the Patreon is here for if you find that the resources are useful and you want to just sort of chip in to make this thing sort of go around, then it is very much appreciated. So with that, I am going to leave it here. Remember, the blueprints are always available in the description below, and hope you'll find this interesting and hopefully inspiring in terms of the base. And if you are going to comment about why there are green concrete in the background, well, you're going to have to come over to Twitch to figure out why we have green concrete, and for that matter, all sorts of other colored concrete. That'll just be something that happens that you will find out on Twitch. Thank you for watching. Hope to see you again here on YouTube, on Twitch, or on Discord. Thank you for watching. Take care, and as always, stay effective.